So hello everyone, welcome back to Algo Daily. In this video we are discussing LeetCode daily challenge word subset. So we are also discussing in this problem in their implementation and their time and space complexity, and also we have dry run their example test cases. So in this problem we have to given two strings array words1 and words2, and a string b is a subset of string a if every letter b occurs in a including multiplicity. So let's discuss this whole problem statement and also discussing their definition for better understanding. So now discuss their. So we have to given a words1 and words2. Okay, so words1 and words2, these two list we have to given, and first is our subset. What is our subset? So basically a subset b is a subset of string a. We have to given string a. Okay, and also if every character in B appears in A and the count of each character in B is less than or equal to its count in A, so these are our subsets on this problem. So like for example, we have to given, let's suppose E. Okay, E is subset of Facebook. This is our let's suppose this is our example. Okay, and this E is at least one time on their string. So this is our subset. Okay, and second thing, that we have to given a universal. This universal, what is universal? Universal string is basically a string a from words a from words 1 is called universal if it satisfy all the following conditions. So what are these conditions? So the condition is for every string b in words 2, b is a subset of a. So this is our definition of universal string. Okay, and we have our goal is, what is our goal? So basically our goal is to return all the universal strings from words 1. Okay, so here words 2 is given for their values, and this word 2 is checking on word 1, and we have to find or we have to return their universal subset is present word 1 or not. So this is the simple or straightforward explanation on this example or their problem statement. So now let's discuss their example 1 for understanding. And so now we have to given words 1. Okay, so words 1 we have given here is Amazon and Apple, Facebook, Google, and LeetCode. Apple, Facebook, and third is our Google, 4, and LeetCode. Okay, so this is our words 1, and words 2 we have to given e and o. Words 2 is our e and O. So now let's check for all these conditions, and this is valid or not, or we have to return the universal strings. So our requirement from word 2 is the character in word 2 must appear in every universal string, like this E count or this O count is present on their words 1 string. Okay, so now we have their combinations, like we have to require at least at least one count of every this character or a word. Okay, so our requirement is this E must appear one time and this O must appear one time. So this is our condition. Okay, and for each string we have to word 1 for string in words 1, check if it meets the requirements. Okay, so first we have to check with Amazon. Now we have to create a frequency map for storing all these frequencies, like this A frequency is 2 time, M frequency is 1 time, Z frequency 1 time, O frequency 1 time, and N frequency is 1 time. So we have to calculate their frequency, and after this, if the frequency at least one time of E and O, so we have to store this value. Okay, we have to store this value for their universal. Okay, so now their frequency, this frequency of this one is A frequency is occur 2 time, M frequency is 1 time, and this Z frequency is 1 time, and O frequency is 1 time, and last we have here N frequency is 1 time. So this is our frequency map for Amazon. And next we have there is Apple. So this Apple frequency map, this frequency of Apple, we have to here A frequency map is 1. Okay, and this P frequency map is 2 time, and this L frequency time is 1 time, and E frequency time is 1 time. So now we have to calculate all these values, Facebook, Google, and LeetCode. So now we have let's suppose we have calculate all these frequency map. Okay, so now after this we have to check with these values, words 2 values. Okay, so now here E is equal to 1, O is equal to 1. So here E is not present but O is present. This is not a valid condition for our example test case or our problem statement. And this E is present 1 time here, and we have to given this. Okay, so here Apple is all this Apple is not containing their frequency map. Okay, this is not a valid condition because of here E is present but O is not present. And same thing for Facebook, here E is present at least 1 time but O is present 2 time, but we have to consider it it present at least 1 time but it contains 2 time, it present 2 time, so we have to take this as our universal string. So this is a valid condition, and this Google is also a valid condition for this E is present and O is present, and this LeetCode is a valid condition. So now we have getting our 3 valid condition or 3 valid universal strings. So the answer is, what is our answer? First is our Facebook, and second is our Google, and third is our LeetCode. So this is our answer, and we have to getting their actual answer, Facebook, Google, and LeetCode. And same thing for next example. So in this example we have to given Amazon, Apple, Facebook, Google, LeetCode, and in this time we have to checking with L and E. Okay, L and E, and at least this L frequency one time and E frequency is one time on present on their words one string. So here is not present, but here is present, here is not present, here is present, and here is also present. So here the frequency is Apple, Google, and LeetCode. Okay, so I hope you understand the logic on this of this example test cases, and now let's discuss their code implementation for better understanding. So first we have to use on this problem statement, we have to use once again we have to use a frequency map and find their one frequency map, and second is our max frequency for calculating their uh, size. Okay, size of 26, 0, and this is our frequency map to store maximum frequency requirement for each letter. Okay, and this one is to iterate all over the things. Okay, so now let's discuss their implementation part for we know how this problem is occurring on their example test cases and lie their example test cases basically. So one second. So first we have to create our frequency, max frequency. This max frequency is basically to create a frequency vector to calculate their size and initialize with size, and it store the maximum frequency requirement for each letter. Okay, for each letter of words 2. Okay, and this we have to iterate, and now this it we have to uh, iterate with words 2, and to create a temporary frequency for store the count of each character. Okay, this store the each count of frequency, and now this one. Okay, so this one is to compute the position in alphabet. So which position? This ch minus a, this ch minus a is performing. Our a is 0 and b is our 1, and so on so on. Z is equal to z is our 25. So so this line performing these conditions. Okay, so after this we have to update their max frequency vector, and this is our updation, and this ensure that max frequency store the highest requirement basically, to highest requirement for each character across all string of words to word 2, and this is for our finding and update their max frequency. And after this, one second, and after this we have here the answer. This answer is to store the universal string from word 1, and this one, this whole idea is basically this subset 1 is to our flag for determine the this is our universal. We have to get their universal string, and after we have to create their frequency for count, store, and each of the every character, and this is the same procedure we have to proceed before. And this one, okay, so this purpose is to compare the frequency count. This one is the compare the frequency count of it. Okay, and this is our conditions for valid one. Okay, to find their universal string. And so after this we have to subset of 0 to mark it is not a universal substring for this condition, and we have to directly break. Okay, and after this, if not their subset is present, then directly we have to push their satisfied condition, which we have to push into your answer vector, and directly we have to return their answer. Okay, so I hope you understand the logic on this code. So this is a simple code for their word subset problem. And now let's discuss their time and space complexity. So now time complexity. So the time complexity of processing words the processing words of two is we have to compute their frequency for each of the string. So the time complexity of this is O of 26 time we have to compute, and there this words 2, this is our words 2. Okay, and this is our O of n into n into 26. So this is our time complexity and of words 2. Okay, of words 2. And now we have to calculate with words 1 time complexity of each string. We have to compute their frequency and their compare with the max frequency. So their time complexity of this code is O of 26 into n1, same as uh, previous one. Okay, this words 1 we have to ensure this is n1 in this case. So the total time complexity is the total time complexity of this code is O of 26 into n1 plus n2. Okay, n1 plus n2. So this is our constant. So total time complexity of this code is O of n1 plus n2. And in their space complexity, this is our space. So space complexity, we have to create a frequency map, and we use two frequency vectors, and max frequency and frequency only. So this is we have to initialize with O of 26, and also we have to create a result answer vector, and this depends on their size and their universal strings that are stored on this answer. So the total time complexity of this code is, let's suppose this is k for we have to initialize with, and this is 26 into k. So sorry, 26 plus k. So the total time complexity of this code is where k is our size. So the total time complexity of this is O of 26 plus k, O of k. So I hope you understand the logic and their implementation part, and also their time and space complexity of this code. So thank you everyone. Thank you so much.